So I did want to include just an explanation of this this context box in order to make the analysis and your assignment this week a little bit easier. I wanted to first talk about kind of this first section here and what's going on. Because we do need to know kind of the direction that these different charges are going. And this presents a good opportunity to analyze this electric field and review some of the things that we kind of did before anyways. Okay, so up here we have this variable power supply, and that's important because we see that this side's hooked up to the negative side, which would make this conducting rod negative, and then this conducting rod would be positively charged. So we have kind of two parallel plates there, which means that we have this electric field then, again, as the direction a positive test charge would move. So we have this uniform electric field between those two rods, which would look like that. Now, because we have that uniform electric field, our chloride ion and our sodium ion are going to experience an electric force. Now, because they're oppositely charged, the electric force acting on each of those is going to be different. Because the chloride ion is negatively charged, the electric force experienced by the chloride ion is going to be upwards in this diagram, whereas the sodium ion is going to experience an electric force downwards. So they will have an electric force, and they will start to accelerate between those conducting rods. So that's important kind of when we go down to this bottom section here, which is what your assessment this week is based off of. We have this tray now is sitting in between that horseshoe magnet. So we need to take this diagram up here and then flip it down here. So now they're still hooked up to the same sides. So the electric field is going to still be going that way kind of in the tray. But what we care about is kind of the movement of those particles in that external magnetic field. Okay, so that's kind of this week's assignment is talking about what's happening in this diagram. So we have these, the sodium and chloride ion now in this tray. They're still moving because of that electric force, but now you're going to be using your hand rule in order to analyze kind of the magnetic force experienced by those ions as they move through this external magnetic field. That's what this week's assessment is based off of.